these are going to go over some of the problems on page 92, and this was homework. So I'm going to go over graphing tan and cotan. Now, one thing you have to be careful. For tan and cotan, the period is no longer 2 pi over b, it's pi over b. So here, your b is the coefficient of x, which is 2. So the period is pi over 2. Now, I've got just normal graph paper so that I can space this out any way that I would like. The starting point is, well, my C comma D, we don't have a phase shift, we don't have a vertical shift. For the cotangents, you always want to start by graphing the asymptotes. So always start by graphing the asymptotes. And since we don't have a phase shift, your asymptote is actually going to lie on the y-axis. So I'm going to make that dotted. So my first asymptote will lie exactly on the y-axis where x is 0. Now, the asymptotes are always going to be 1 period away from each other. So since the period is pi over 2, I'm going to make the next asymptote pi over 2 from this. Now, it doesn't really matter how you label your tick marks. I think I'm going to go ahead and let's, just for spacing purposes, let's call this one pi over 2. So that's going to be labeled as pi over 2. And then the next one would have to be, again, 4 tick marks, since that's how I chose to count mine. So that one's going to be pi. So I'm really counting by pi over 8. And then I can just go ahead and graph. I just want to show you that part is not really going to matter. So I'm just going to go from negative pi to pi, since I don't really have a lot of room. So again, that's going to be my y. This is my x. This is negative pi over 2, and this is at negative pi. And that's just how I wanted to space them out so you could see the points that I'm about to plot. Alright, now to get the actual points for my graph, I'm going to go directly in the middle of the asymptotes. And since I don't have a vertical shift, my first point is going to lie on the x-axis, which is kind of like the midline, but these don't have a midline. And then for cotangent, it's always decreasing. So I'm going to go halfway to the left, up 1, and that's just a value of 1, and then halfway to the right, down 1. So there's my value of negative 1. And then I would just draw this little curve shape and put arrows on the ends. And then I could continue that pattern until I've completed all the cycles that I want to show. So again, it's just left, up 1, right, down 1, and then draw in your pattern. Now, if you do have a number like an A in front of that, that's going to create a vertical stretch. So that'll mean that you'll go halfway and up however much the number is in front of the function. So this is probably good enough to show you just from negative pi to pi. And again, I spaced mine out. Yours may be closer together, and that's fine. But I'm doing this just on normal graph paper. Alright, let's look at how the tan is going to differ from this one. Well, the tan ones are a little bit harder. The period is still going to be pi over b, so pi over 2. But for tan, we start with our point. And so the point that we're starting with is 0, 0. So now, if I look at my y, my x-axis, I'm going to start by plotting the origin 0, 0. And again, your asymptotes are going to be pi over 2 units apart. So to get the asymptotes, now I have the middle point. So I need to go halfway to the right and halfway to the left. Well, I'll go ahead and space this out the same way. So the last example, I counted every 4 as pi over 2. So this example, I'm just going to go ahead and do the same thing. So let's see. 1, so half of, let me write this down first. So this will be pi over 2. And this will be negative pi over 2. Now, if I take half of pi over 2, that is pi over 4. So really, I have to draw my asymptote to the right. It's going to be at positive pi over 4. And to the left, it's going to be at negative pi over 4. And again, the distance between would be pi over 2. So it looks to be like every 4 tick marks away, I would just continue to have that pattern just like I had 1, 2, 3, 4, except for the fact that they're not going to be at the same spots. So I'll go ahead and label them 1, 2 after I draw these in. Alright, so let's see what I have. So it looks like this is going to be negative pi, and on the right I'm dealing with positive pi here. So again, if I'm counting, if the fourth one is pi over 2, it looks like I'm counting by pi over 8s. So this would be like 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. And so pi is actually 8 pi over 8. So if I wanted to continue, that's 8 over 8, and this is going to be 9 over 8, so this would be 10 over 8, which reduces to 5 pi over 4. So that's just one way that you can identify each of these marks. Now, to draw in the actual function, I'll do that in green. This one's different because it's going to increase. So again, I don't have a stretch, and I'm right on my midline, so I'm going to go this time to the right up 1, so that value is 1, and left down 1, so that's a negative 1. So this time it's going to look like this. So you would just continue that. I'll go ahead, and the middle point between these asymptotes is going to be at pi over 2, so right up 1 halfway, left halfway, down 1. And again, it just depends on how many cycles you want to show, but that pattern is going to continue like that, and then it increases from left to right, and so that's one thing that you do have to remember, is the fact that it's going to increase from left to right. And if I wanted to show half a cycle here, well, I could, as far as putting this point here, and just show this much and stop there. So basically, that is what the tan graph looks like, and again, this is with a period of pi over 2. So all the asymptotes are pi over 2 apart. All these critical points are pi over 2 apart that are on the x-axis. Now, this next one has a vertical stretch of 3. So really it looks similar to that first one I did, except for the vertical stretch is 3. So the period is pi over 2, because b is 2. Now let's see how that vertical stretch is going to affect this. Anytime you're doing the cotangent graphs, you start with the asymptote, not with the point. And since I don't have a phase shift, the asymptote is going to be directly on the y-axis. Now again, I'm going to count pi over 2 to the right. Well, this time, I think I'll go ahead and count by pi over 4s. So I'll go ahead and call this pi over 2, and this will be pi. And then this will be 3 pi over 2, and this will be 2 pi. So you can, basically do the same thing over here, just make them negative. And I'll just stop there. So now, if I have a period of pi over 2, you see how, because I labeled these as I counted by pi over 4s, now they're going to be closer together. So they are going to be pi over 2 units apart. So for me, that would be 2 tick marks. I'm going to have a lot of these. And then I'm going to fill in my points. So directly in the middle, because the midline's the x-axis, I will pick a point. And because it's cotangent, it's going to decrease. Now here's the vertical stretch. Here's where it comes in. Halfway in between the point and the asymptote, instead of going up 1, you're going to go up 3. So literally, that's your point. Instead of going down 1, you're going to go down 3. So halfway to the right, down 3. So this, it almost looks like a straight line, but it's not. It's supposed to have a little bit of a curve. That's why I like to spread these out a little bit, because it's hard to draw them when you don't spread them out when they're so close together. So that's basically what a couple cycles looks like, just so you get the idea. You can see that from left to right it decreases, and that's what the cotangent function does. So you start at the asymptotes. All the asymptotes should be pi over 2 units apart. Alright, let's look at another one. This is a tan one, and this time it has a phase shift of right pi units. So let's go ahead and get the period. The period is just pi, and that's because b is 1. We don't have a vertical stretch, a is 1. So if the period's pi, the first thing I want to do is I want to use my starting point. So that's going to be at pi comma 0 because d is 0. I do not have any vertical shift. So that means the x-axis is going to be like my midline. So let's go ahead and count by, I'll count every other one pi's. So we'll do that. And I'll just do the same thing on the negative. And again, if you want to count by, every fourth one is pi to spread it out, you can. So this is just going to give you an idea of how to do the tan ones. Now, because I am starting with pi comma 0, that's the point that I'm going to plot. And if the period's pi, I'm going to do half the period, so half pi to the right and half pi to the left. Well, you see how I use 2 tick marks for pi? So that means I'm counting by pi over 2's. So when I draw in the asymptotes, I'm going to go 1 tick mark to the right of that and 1 tick mark to the left. And that will give me a distance of pi because every 2 tick marks, is pi. So now I can finish up, and again, I could just go ahead and count every 2 tick marks, put an asymptote. I want to draw a bunch of these in here just to show you. Now I want to go ahead and put the points in so you can see what the graph looks like. I already have my starting point, and that's pi comma 0. So I know halfway to the right, up 1. So again, this time I'm only going to go up 1 because of the vertical stretch is just 1 there. So halfway in between the point and the asymptote, up 1. And then halfway to the left, down 1. You see how this increases from left to right? That's what the tans are going to do. So same thing here. I'll plot my starting point on 2 pi, halfway up 1, halfway to the left, down 1. Alright, let's try another cycle. So again, I'm going to plot this time the 0, 0 because that's actually pi units away from my starting point. So halfway to the right, up 1, halfway to the left, down 1. So you see all my cycles look the same. So once you have one cycle drawn, it's pretty easy to duplicate them. And that's what it looks like. So this is the tan, and it increases from left to right. And you could easily get the domain and range. The range is going to be all real numbers for all these. All right, I'm going to do this extra problem just to show you what happens here. Well, the period is pi over b, so pi over 3. So let me, if the period's pi over 3, you can count by pi over 3's. I think I will do that. So I'm going to count every third is going to be pi. So 1, 2, 3. Now you know what, actually, now that I think of this, I think I'm going to count by, I think I'm going to spread this out, because if I make this, I want to do half. So let's do pi over 6's, actually. So let's do every 6. 1, 2, 3. Alright, that's actually going to be better. That way, this will be, so if I count by 6's, really, this first one is pi over 6, and then 2 pi over 6, 3 pi over 6, so I can continue in that same fashion. So 1, I'm just going to go ahead and label it like that, and then this would be negative pi over 2. So let me make sure, 1, 2, 3, 4, 5, 6. So I got my negative pi over 2 on the wrong tick mark. Alright, here we go. Alright, now, my starting point is going to be 0, negative 4. So this one's actually going to have a vertical shift. Now, for teaching purposes, I don't normally make them this dark. I'm going to go ahead and put what we call a midline, but it's not really a midline. It's just where the vertical shift occurs. So I can put my starting point on 0, negative 4. So let's do that. So 0, negative 4 is where I start. Now, half to the right, half to the left. Half of pi over 3 is pi over 6. Well, that tells me that I am going to be making an asymptote at pi over 6, and then half to the left at negative pi over 6. So you see these asymptotes are going to be pretty close together. And I'm just going to show you what one cycle looks like. I'm going to go over halfway up 2, because the stretch, over halfway down 2. So again, this is pretty skinny, and it's just easiest to count by pi over 6s.